Let's take a look at example number 3 for mean value theorem for integrals. It says find the average speed. Okay, so this is basically mixing with another lesson we've done, which is particle motion. Over the time interval 1 to 5, okay, and this is going to be in seconds, so from 1 to 5 seconds, of a particle whose position at time t is given by the following equation. So this is the position equation. S of t equals t cubed minus 6t squared. And that meters per second thing should not be there. That should just be meters. Okay, so its position is given by meters. All right, however, we want to figure out its average speed. So in order to do that, remember that the derivative of position is velocity, so s prime of t, but taking the absolute value of that will give us speed. So we want to figure out the average speed of this particle, and we're given its position equation, which again is in meters. Okay, the units for speed would be meters per second. And it's from 1 to 5 seconds. So how do we do this? Well, again, let's just follow the steps we've been doing before to get to the right answer. So first of all, we have to have an interval. The interval is from 1 to 5, and I'm just going to write seconds there. Next off, plug in f of x, a, and b. So f of x, again, is not a position function. It is our speed, which is the derivative of the position, and take the absolute value of that. Okay, so we're going to integrate from 1 to 5 of 1 over b minus a, so it's going to end up being 1 over 4 of, so 1 over 4 times the integral from 1 to 5 of the speed function, which is the absolute value of velocity. Now, to do this, we have to take the derivative of the original formula they gave us. Derivative of t cubed minus 6t squared is going to be 3t squared minus 12t using the power rule. And then the speed of that is just going to be taking the absolute value of this. So put absolute value bars around there. This will be my speed function. So I want to find the average value of this, which came from my position function. Simple enough, right? To integrate absolute value, we must determine where v of t changes sign on the interval 1 to 5. We've taken antiderivatives of absolute values. If you want to, you can go back and review that lesson. But basically, you've got to figure out where it crosses the t-axis. So to do that, you set it equal to 0. Pull a 3t out. That's the GCF of these two terms. Set them each equal to 0. You get t equals 0 for the first one and t equals 4 for the second. So this is where it crosses the t-axis. Then you want to do a sign chart. Okay, so from 0 to 4, I'm sorry, from 1 to 5. So again, we're finding the average value of this function from 1 to 5. And we got, when we did this, we got 0 and 4, right? So the 0 won't matter because we're just going from 1 to 5. 4 is the only number that matters. So we need to figure out for this absolute value function what's inside the parentheses where it's less than or greater than 0, because if it's less than 0, we have to make it positive. So we're going to try the interval basically between we could say this is between 1 and 4, right, since we're going from 1 to 5, but we can just plug in 1 because it's not going to give us 0 back anyways. We can plug in 2, 3, and any of those numbers we plug in, we're going to get negative number back. That means that the velocity is negative on the interval 1 to 4, or 0 to 4, it doesn't really matter, and therefore we're going to have to take that part of the function and make it positive, which basically means multiplying it by -1. It'll flip it up above the t-axis. From 4 to 5, however, we get a positive number back, so we won't have to do anything to that part. Okay, so the velocity changes sign at t equals 4, so the new integral is as follows. We want to take the absolute value of our integral from 1 to 4. Okay, again, another way to do it is just to make this formula. If we go back to this formula right here, another way to do it is just to make this negative, so it'd be 12t minus 3t squared, integrate it, and then find the integral, and that's going to end up giving you a positive number back. Or another way of doing it is just finding the integral and then taking the absolute value of that. So that's what we're going to do in this case, from 1 to 4. From 4 to 5, it doesn't matter because the velocity is positive anyway. And don't forget your 1 over b minus a. That is a very, very common mistake. I've made it myself, is to forget to include the 1 over b minus a in your answer. After all, this is the average value. It's not just the integral. Okay, so next thing we want to do is fix something that's wrong here. 1 second. Okay, so now I realize why I decided to do the absolute value after I integrate velocity, because the antiderivative velocity is just position, right? And that's a formula they already gave us. So why reinvent the wheel? In other words, if the position function was given to us, okay, this actually won't matter, because if we just find the definite integral of speed, if we get a negative number back, we can just make it positive, right? And that will give us a positive variance. So why not just do that? So basically, we're just going to be evaluating our limits from 1 to 4, plugging into the position function, making it positive. And then from 4 to 5, it's already going to be positive, so we don't have to make it positive. And that's why it's very useful to break the definite integral up into these two pieces, from 1 to 4 and from 4 to 5. So that's why I did it that way. I don't have to retake the antiderivative, since I already know the original function s of t, the original position function, which is t cubed minus 6t squared. So for the first part, I'm just going to evaluate that from 4 to 1. Now remember, because I know that part of the velocity is negative, I'm going to the absolute value of whatever I get to ensure that I get a positive number back, since we're talking about average speed, right? Average speed has to be positive because speed is positive no matter what. For the second part, it won't matter because I know it's going to be positive. The velocity is, and therefore the speed's going to be positive. So I can just find whatever the definite integral of that is. So basically all this is just math. I'm plugging in 4, and then I'm subtracting when I plug in 1 for my first part. Here's when I'm plugging in 1. And here's when I'm plugging in 4. And then for the second part, I'm going to use some different colors. I'm plugging in 5. And then I'm subtracting when I'm plugging in 4 into my position function. Because, again, the definite integral of velocity is position. You would use the position function. The antiderivative velocity is. Okay, so for the first part, I'm just doing some number crunching here. Don't forget, remember to always drop down your 1 over b minus a, 1 over 5 minus 1, which is 4. And then evaluate all this stuff. 4 cubed is 64, 6 times 16 is 96, so on and so forth. Make sure your signs are correct. This is minus, minus, minus becomes plus, and so on and so forth. In fact, I'm going to double check all this to make sure. Okay, that's going to be plus. Plus 125 minus 25 times 6, which is 150. Okay, all looks good. So we do some number crunching here, and we get, now remember, for the first part right here, this is going to give me negative 27, right? But because I'm making it positive, it's going to end up being positive 27. That's because we're talking about average speed. Since the velocity is below the t-axis from 1 to 4, we need to take that area and make it positive so we can find the average speed. So once we get to this point right here, this tells us that basically the area under the curve from 1 to 4 is negative 27 for velocity, but to find the average speed, we make it positive, make it positive 27. So this becomes positive 27 plus 7, which gives us 34. Then don't forget the 1 over 4, so we get 17 over 2, which is 8.5, which is our answer. So the final step is to answer verbally. The average speed of the particle from 1 to 5 seconds is 8.5 meters per second. Going back to the original problem, which I always like to do, let's read it again together one more time. It says, find the average speed over the time interval 1 to 5 of a particle whose position is given by this. So basically, if you were watching this particle move, right, from t equals 1 to t equals 5, so let's say this is t equals 1 and this is t equals 5. Okay, its average speed, basically all the speeds added together divided by the infinitely many speeds, its average speed would be 8.5 meters per second. Okay. At some points it might be going slower, at other points it might be going faster, but its average speed would be 8.5 meters per second. That's it for this question on average speed. If you have any other questions about it, let me know.